guess we should start off with where we are now. So, as Neal mentioned, the 6.16 kernel came out last Sunday, which means that the merge window is open for 6.17. It's actually been, as far as stuff that actually has gotten merged, it's been a fairly quiet year. The file systems have added a bunch of miscellaneous features,
as they are wont to do.
And slowly creeping towards actually having Rust support in the kernel, and Rust support in Debian stable, which is a giant milestone. Hey, look, it compiles with an ancient version of Rust. And so, as the clock ticks down to the 2025 LTS, it'll be interesting to see if anything major happens in the next few months, or if things just kind of, head to the end of the year and off we go. So, let's see. Why am I in the middle? All right, Zach, want to talk?
Oh, I don't have much.
All right.
Answer questions.
So I think, my...
That looks off. Oh, okay. There's just no light on.
Yeah, so I think my place of work generally tends to be dealing with the end users of the kernel. We do a lot of work with people who are consuming kernels from various sources, and those are usually some vendor who really doesn't know what they're doing. And you end up looking at a system where you have a ancient, say, a 5.15 kernel, and then going, well, we have to think about keeping these products alive for 5-10 years. I don't know about you, but I don't want my car infotainment system being rooted by some script kiddie and playing Aqua's Barbie Girl on loop until you pay them to stop. And yeah, we did. Yeah, so that's where I'm interested in seeing how these sort of projects deal with long-term maintenance, vendor forks, and that sort of stuff. Who wants to?
Yeah. For me, my main thing is I deal with one vendor kernel, which is the AsahiLinux tree. Although at least it's not in the frozen and broken state that a lot of other vendor kernels are. The thing that has been kind of at the forefront of my attention has been seeing through the process of getting all this stuff upstreamed into mainline, so that my life doesn't suck as much as I go through to make new releases for the kernels into Fedora Asahi Remix and CentOS Hyperscale Asahi now, which but on top of that, in addition to the Asahi stuff, I also flit around in storage. Some of the people that do various advanced file system stuff will know that I am present and reviewing or discussing stuff on a very regular basis, particularly in Btrfs, where I tend to be very active there. The Btrfs space has been very interesting. The past 5 years has been a lot more driven and a lot more evolutionary, successful evolution than in the prior 10. And that's, I think, been largely because since Fedora adopted Btrfs in 2020, we've seen a lot of distributions reconsider and then adopt and then drive and build features on top of it, leveraging the great technology that the Btrfs file system has. And I've been very pleased with how things have been moving forward and evolving further to support more and more use cases. And to be honestly, at this point, I would, even with you factor out the fact that I've been using Btrfs for like almost 12 years now, I think at this point I would solidly say, like, if a Linux distribution isn't defaulting to Btrfs, they're probably doing something wrong, because it gives you a very good balance of all the things, and the team is very active, and actually some of the friendliest Linux kernel developers that I've had the pleasure of working with, and they're very, very incentivized to help and be helpful, both to users and the distro maintainers. And so in many respects, I think the relationship that the Butterfest developers have with their larger community is what the rest of the Linux kernel project should emulate. Not everyone is at that level, and some are a little further ahead. Like the graphics people are actually, I think, probably the gold star for this stuff. But yeah, we'll see how things go. It's been a very interesting ride. The Rust stuff in particular has been a roller coaster.
Yes.
Let's see. So, I guess from my perspective, I consider, I guess, the kernel mature, really mature at this point, right? And I'm happy to see a lot of new community members join the community from the rest of the world. And as you were saying, yeah, it's a roller coaster for sure, but at the same time, it's gone in the right way, right? So I think that that's going to open up a lot of doors for a lot of innovations. And what else? I think that complexities in the kernel are evolving as well too, but there's also a lot of opportunity to try to address those complexities with new innovations. I'm really excited about the evolution of eBPF and the expansion of it and the implications of that for a dynamic kernel. I think that slowly you will start seeing more innovations happening in that space. I think that the combination of both that and Rust will enable a lot of future innovations that perhaps we hadn't considered before. I'm also happy to see these little small conferences happening and focusing on subsystems. I think that that's pretty live and well. And I guess I'm curious more than anything, what are people's interest in this space? Do you guys have any particular issues, pain points you guys would like to talk to, or ask questions about the space?
Mm-hmm. I mean, anybody want to go first? All right.
I'll lob a nice little bomb into things. What are your thoughts on AI assisted and perhaps AI even written submissions to the kernel? Why, Neal?
Funny you should ask about that. I got my first submission 2 days ago. So I've been having landed online Fisk for XFS last year, and I've started moving on to a new project, which is kicking all the file systems out of the kernel, because frankly, we shouldn't really be doing all that parsing stuff in the protected kernel space. We could just banish all that to user space where we can actually set up appropriate walls so that when you plug in, so that we have some tests.
They're not real.
So that when you get tempted to pick up the USB stick out of the parking lot and shove it straight into your boss's computer, that maybe you won't just immediately breach their systems.
Just maybe.
So that new project has involved actually looking at fuse code and old fuse drivers, and so Mir Goldstein sent me I think a Claude authored patch set fixing up the old Fuse 2FS server and E2FS progs to bring it somewhat more up to date with modern Fuse. So I started looking at it and thought, oh wow, okay, well, this actually sounds like a reasonable use of something, because potentially, yeah, it's a lot of mechanical stuff. There's a lot of Fuse servers hanging out there on the internet, which I assume they have scraped at this point. So maybe this thing actually can just build a kind of mindless statistical model, if you will, and actually crank out something that works.
I've been talking to one or two people about this, and we haven't seen a lot of external submissions yet, but people are saying that these tools are helping them do their day-to-day management, and maybe they're not writing all their code with it, but they're using it for like suggestions of how you would go about doing documentation updates, things like that. I think we'll probably see a lot more.
Yeah, I mean, I've seen my own personal usage of this stuff. I've mostly been using it to try to guide myself to be able to use things correctly. Like it'll like running locally, it'll analyze the repository I'm working in and stuff like that. But really, I think I've mostly limited it to mechanized work, like writing test cases and things like that. My current worry about this current flavor of AI stuff has been that when you talk about trying to develop code for new things and you're talking about new interfaces or new things that it hasn't been aware of, new concepts, it's not really guessing. It's more like pattern matching and failed pattern matching at that. So my worry is that we're going to wind up seeing more error-driven code rather than, test-driven or concept or architecturally driven code, because error-driven code is a whole lot easier to pump out with these things. So like it's based on, oh hey, this didn't work, so I just tell it to whack it with a hammer again and again. I think the term for this is vibe coding or something like that. But like it's basically error-driven development, and that is super not fun to be on the other side having to review it or even to try to figure out what it is.
We're already getting submissions like that in the kernel.
Yeah.
Code patches that are clearly wrong because somebody hit a warn on in the kernel and they got something to pound on the source code until it stopped generating the warning, but it's completely the wrong fix.
Right.
I think there's an ext4 patch yesterday where their solution was, well, we're leaking a struct inode object, so we'll add another counter to the kernel module to make it impossible to unload the module. Like, well, yes, that does get rid of the complaints about the leaked inode, but maybe we should fix the leaked inode.
I want to hurt somebody for that.
So I have a lot to say about that topic. It's one of my areas of passion, and I'll have a full talk dedicated partially to this. But to not, spoil some of the things that I will talk about, I think that from my perspective, it's long-term going to reveal a lot of interesting concepts of growth. So it's just growth from my perspective. And that implicates changes that are likely essentially being pushed and shoved down people's throat, which is basically proper structure, proper testing, and better semantics. So that combination accelerates the innovation that we will need to adapt to. And I think I'm interested in that space and that evolution and what that means. And I'm actually really excited about the implications of the enhancements of language, like Rust, for instance, in its strong type interface, with the power of AI. So I think that's opening up a different world of engineering philosophy in a way, but also structure.
Yeah, I was looking at AsahiLinux thread on LKML this past week about adding some kind of the beginnings of codified standards in the Linux kernel about AI usage. And one thing that really occurred to me from Amir Goldstein's patch set is that I think I want to actually say to stump for, if you're going to use a chat bot to generate code, that we should actually make you paste the conversation you had with the chat bot into the commit message. Because that way, well, we can at least try to inject some reproducibility into the process where I can go and try it and see what happens. But also, otherwise, it's just a bunch of random words that are thrown at you, and some of that might just be, hey, could we add just enough friction so that we avoid the AI slop problem? Because we already started that with Syzbot 10 years ago, and it's kind of gotten to that's at least moderated to the point where it's acceptable-ish, but it is still a machine that finds bugs in the kernel, and figures out what the reproducer codes are, and then throws the 0 days and exploit code onto public mailing lists and says, "LOL, your problem."
Yeah, I mean, I've actually chased down one or two of those, and some of them have been really strange. But yeah, I think we also need guidance about if you're using AI to author your stuff, is this actually your copyright or not? My friend actually found that an AI pushed some code at him, which went for a suggestion. He realized he'd written this 10 years ago, and it still had some of his misspellings in it. But yeah.
At least it was his.
Yeah, at least it was his. And we're seeing this a lot with a lot of our customers. They're being very careful with what they're doing, but they're seeing that there's an accelerating factor on how AI is improving for these sort of things. So it might well be by the end of the year we see better AI contributions. So
Yeah, I think the thing that's going to be tricky is whatever guidance or guidelines that we have for this. One of the core things that's going to have to be part of it is figuring out how we deal with the attribution parts of this.
Yes.
Because I know that there was one proposal that said code developed by Claude AI, and I'm like, I don't want code developed by to be used for this purpose. This is not right. I think probably what's going to wind up happening is a brand new tag's going to be invented.
Mm-hmm.
Mangled by. Yeah, there we go. Mangled by.
I could think of a better tag, but that would be a COC violation.
Yeah.
So I mean, we've been using tooling to also enhance the kernel using grammar. Just that it wasn't neural networks before, right? Coccinelle is a perfect example of this, right? And I embraced heavily the tag generated by Coccinelle engine, right? So I think that attribution to a AI agent is certainly useful, and that's why I use that tag myself. If I am using AI to generate code, I will be explicit about it, and I use generated by, and I use the engine or a neural network. But I think it is important also, and I do like the idea about the prompt stuff. And I'm spoiling part of my talk, but I basically am publishing a lot of the prompts that I'm using for some of the stuff that I'm working on. But I think that the question for the prompts, I think, would be difficult to scale based on my projections so far. So I think that we may need a separate repo or something like that to point to the original prompts, and kind of like a museum is what I would call them. And then once it gets merged, refer to the respective commit that actually generated that. I think that would prove useful to the community, but also to future neural networks as well.
Mm-hmm. I mean, to some extent, there have been kernel programmers who have been using automated code changer programs for quite a long time, like Coccinelle. It's different in that at least you don't have the attribution problem of, okay, where did the words that it spat out actually come from anyways?
Yeah, but it's not just that, right? So there are Linux kernel developers, I won't name any of them, but they use IDEs that have things like IntelliSense and whatever. And you know what? Those consume the projects, and they will do things. They will create transformations. They'll do inference based on it. Stuff like IntelliSense has existed for decades. And I personally have always used stuff like that because I'm not going to remember how everything bloody works in a sufficiently large project.
Tab completion is nice.
Tab completion is great. Tab completion with documentation references is even better. But those are all some definition of code generation. There's also scaffolding, test stuff, boilerplate. One of the things that we've never seriously talked about in open source development is what the heck do you do about licensing boilerplate? Because when you create a project in Qt Creator, Qt Creator is unusual in that the Qt company has licensed all of the templates under BSD2 clause. But if you use, for example, Visual Studio Code, those templates don't have license data. What do you do? And most people argue, oh, this is sufficiently mechanical that it doesn't matter. But how do you know that? You don't.
Mm-hmm.
And so I think what we're going to have to come down towards is what is our willingness to accept this stuff, and how do we create a chain of trust for generating code in this manner. And like maybe that's prompts being documented, maybe that's also having the generated by tag, which I like. That's a nice I like that phrase, generated by. And maybe that is, instead of putting in the commit, we put this in the files. And because as the code changes, you want to be able to see where the origination point is. Like back in the days where we would say, we'd list the authors in the source files. Maybe it actually makes sense to do where the generator of those code listed in there. I don't know. There's a lot of things to think about for this stuff. It's going to be a hard thing that we'll have to wrestle with for the next couple of years.
Yeah, I mean the nice thing about having humans putting their names into the source code files in XFS is that means every time we find a data corruption bug, that's a bunch of people we can email to be like, hey guys, what's going on here? It's harder to know, what do you do about Claude?
Yeah.
Or whoever drove Containerizing, because I still don't know how to write the patches for those things. I'm kind of glad that Luis is mentioning using AI to generate the Containerizing patches.
Yeah, I mean, if somebody can do a really good guide on how to write Containerizing scripts, we'd love that. I still don't know how to write them.
Yeah, so I tend to try to test several neural networks on to see how they're performing in terms of being able to understand Coxinol over the years and months, and it's gotten much better. I'm not sure if they really started already trying to include it as part of their training, but I suspect so, because the quality has just gotten tremendous. So the most complex things that you can do with Coxinol would be the iterator component. I don't know if anyone here has dealt with that or used that. It's a kind of like an advanced feature for Coxinol when you want to grammatically go through this AST and then just iterate over a whole bunch of series of cases where you're going to find this specific grammatical component. So that was one of the most complex parts that you can deal with so far from my experience in working with Coxinol. So it actually works really well. So much so that now I actually have integrated some Python script into KDops, which allows you to use a Python script to basically use the generator component to dynamically generate your patches the Coxinol patches that you need for what it is that you want to do. So it's kind of abstract. Basically, Python can now generate Coxinol for you for specific use cases. If you want that and interested, let me know. I have a script that does that for you.
I mean, I've tried to swear off doing tree-wide changes, so it's been a while. All right.
We've got questions from the audience.
Woot. All right. Well, I can try to bring the microphone to you and hope it doesn't screech.
I have a hunch/hope that the trend in disposable kernel forks will actually blow back and give more of a commitment to mainline kernel support in the long term.
Anybody want to take that one?
Actually, you should. You're all about the disposable kernels.
Really, we'd rather not be, and we find this a lot with the sort of end customers we're working with, is that we need mainline, and this is the argument we make with them: is how are you going to deal with a product? So a lot of our work is around automotive, so you have to think about 10, 15 years, depending on where you are, support. And if you've been given a massively out of tree thing, you either have to spend effort getting it mainlined, or you have to go to the vendor and go, actually, what on earth is going on here? And so, yay. And then and then you get customers coming back to us going, well, it's 3 years down the line. This library that somebody gave us, which is linked against this version of libSSL, which has a problem. How do we get rid of this? How do we relink it? That's sort of one of that sort of things. But we tend to find that actually the best way is just to say, look, let's get down to a minimally what you need and try and see if we can satisfy that from something more mainline. And if so, can we then patch on whatever else you need and either get it upstream or try and make it the most minimally invasive set. But this has all been done case by case basis, and we really need to get some pushback onto a lot of these vendors that lobbing a tree at people is just not something. And we're now saying to our customers, look, ask your vendor these questions before you start. Just absolutely get this before you start your project. Unfortunately, with, say, the automotive, we're very constrained about what we can do because the numbers are not good enough for people to produce a lot of different product. So we're usually tied into one or two vendors, and I mean, Qualcomm have got better, Samsung have got better, but they're still not great in respects.
I think this, I somewhat alluded to this in my presentation earlier, that there's a misalignment in terms of how to, in terms of dealing with the importance of delivering product. From the Linux kernel project's perspective, I think a lot of the maintainers just don't care about products consuming their stuff, and that's perfectly valid. That's fine. Like if it's out of your scope and you don't care, that's okay. But I've also observed, again, during my time doing as part of being in the AsahiLinux project working on upstreaming stuff, is that coordinating to get reviews, to get them up there, to get them in, is excruciatingly difficult at times. It is very hard to figure out how to get the attention of someone to get things to move in a reasonable fashion. And, again, I'm subscribed to a bunch of the Linux kernel mailing lists for the different parts that matter for AsahiLinux, which happens to be a lot of them. And it turns out a lot of the patches just sit there laying fallow. Mm-hmm. It would not surprise me if part of the reason we have all these, what was called disposable vendor forks, is because they've been burned. And the thing is, the only way to fix that is to do outreach back into them and tell them that things are going to change, and then provide essentially empirical evidence that things have changed. But I don't think that's going to happen. I don't think there's an incentive either from the Linux kernel project either to do that kind of outreach. And also, it's not a process that scales. Like, not everyone knows all these people, and it's a networking type thing that, like, you got to know the people to reach out to them.
Yeah. Like you said, a lot of the problem are misaligned incentives, because company A is participating in a subsystem and company B are participating, but they don't necessarily want the same feature sets. So then you see the dynamic where A's engineers find it really hard to get anybody to review their code, and then and so their patches just sit there, and likewise.
It also, with some of these things, you're only doing small changes to a lot of different subsystems. Trying to manage small number of patches across that can be difficult because not everybody reviews at the same rate. You end up holding them, But even within companies, I've dealt with one large company where their own disposable forks had bitten them in the bits that you don't want to be bitten in. It's like they had like 5 different pieces of silicon. They'd forked a kernel I'd written, and of those 5 forks, 2 had 3 bugs in that had been fixed in one of the others. One had a new unique bug in, and it's like, there's another one I'd fixed upstream that they hadn't taken either. It's like, guys, really?
Yeah, I mean, another huge problem is that all of the maintainers are burned out. And at this point, it's really a question of to what degree is the particular maintainer you're dealing with burned out? Is it some or a lot or
So
off the rails?
I have, I did for a while the I2C maintainership for a bit, but that got out of the capability I had the energy to do. But it's not just a Linux kernel issue here. I find that even projects, quite large projects like QEMU, patches just go unlooked at for a while. So one of my colleagues put a couple of RISC-V extensions in, and it took 2 or 3 prods to get even a vague review. And I think if some of these companies, like say even Linaro or the RISC-V Rise project, do need to put some effort into helping these projects along, because it's the only way we're going to get things if actually they donate time to review, maintain, help with the merging, because otherwise stuff just sits and
Yeah, so a question I actually have for you is that, well, part of the reason why the XFS online FISC patch set merging dragged out for years is that I had a very difficult time lining up reviewers who actually understood enough of database theory to understand what online FISC is actually trying to do when it generates a new index. I don't know if that's, and so I've thought about maybe a solution, at least for us, is that we need to be more proactive about helping the file system developers learn about the theories underlying all the code that they're touching, but I don't know if that actually applies to drivers or not, because to me, drivers seem dead simple, but I bet they are not.
Hardware is not simple.
yeah, I'll go with a quick one. Yeah, hardware is not simple and is often not well documented.
Wow.
File systems are documented? Uh-oh.
And you end up with, I mean, this is the other issue with a lot of these SoC people, is that you have a very similar hardware block across a number of different things, but they very rarely build it the same across their thing. It may be different versions, new bugs. So,
and that's why the drivers have all these switch statements with underscore A1, B1, C1.
Yeah, that's going in. I say this is one of the issues I had early on with Samsung, is that they did not understand how to write parameterized code. They had a serial block that they used in every single one of their SoCs, but it was never configured the same way. It would have little extra features, bigger FIFOs, and you get into a kernel and you'd see 20 different copies of the same driver just with some cut and paste done. And it was just, dudes, come on, let's write some parameterized code, make each driver just give a block of data to the core of the driver, and life is going to be so much better.
Yeah, and like when you look at some of the stuff related to being able to sustain and understand these things, like again, AsahiLinux is entirely reverse engineered. So this is even more fun because we have the assumption of not only there no documentation, but no one knows what it's supposed to do in the first place. So, you're going back and you're black box testing and you're poking it with sticks and guess what? Like, your sticks might not be the right sticks, but they're right enough. And I think one of the things that the Linux kernel community is probably going to have to figure out is how to deal with code that genuinely people are not going to know why it works. That is the number one challenge, I think, in the driver space, is that there are no answers to the questions you're asking, because we just know it works because we poked it with sticks enough and things show up in the right way, but we don't know why and we can't explain it. And this is a deep, deep challenge that I think in the earlier days of Linux, like 25, 30 years ago, this was something that people accepted as a fact of life. But we have gotten to a point where now people are used to being able to white box all the drivers. But the reality is that at least for the more esoteric platforms, you're not going to have that. And going back to, these are all black box development is massively uncomfortable for a lot of these people, especially when you're a poor soul who's actually fixed the driver for something and you are actually working for the company that made said hardware, and you don't know because they don't know because they lost the documentation or were required to burn it. I know at least one vendor where they made a piece of hardware for a company, not Apple, but somebody else. They made a piece of hardware for a company. They made it for Linux. They wrote a driver, and they were required to burn all the documentation afterwards. So that was a thing where they literally didn't know anything about the hardware afterwards, and that was it.
Well, yes, I believe I've had some experiences similar to that. We need you to pretend that you never wrote this. Okay.
Those are fun.
All right. Third question.
So I hear there's a lot of kernel maintainer angst out there. And I know that when we talk about it, sometimes that can demotivate more junior programmers from going forth and submitting patches and becoming the next generation. So I'm curious, maintainers, what are the things you wish people would do now that would make your job easier to be a maintainer? And people that have successfully submitted patches, what are the strategies you use to actually get attention on those patches? Because clearly the tracking systems right now don't work as well as we'd like.
Well, I can answer the second question you have because I've submitted patches. Annoy people to death. Legitimately, just ignoring any kind of social decorum and just emailing people until they go and look at it, like weekly or every 2 weeks or something like that. Poking people with sticks is a surprisingly viable strategy. Part of the reason for that is that it's really hard to get the attention, and because these are mailing lists and they're not like web interfaces where you have lists of pull requests where you can actually see and enumerate and see results and stuff like that, it is very easy for all of it to be just drowned out. Like my inbox where I have the filter folder for Butterfest is, I think, 3,000 unread emails, and that is 85% patches. And now I don't speak up and say stuff for a lot of them, but I do actually look and test a good chunk of those. And occasionally I will provide feedback when there's something meaningful for me to say on those. And I think this is true for a lot of the other Linux kernel people that do stuff, is that getting the attention is hard because there's just a deluge of fire hose, and there's no viable sorting path. They're all emails. They're all sitting in your inbox. And there's no mechanism for you to say, okay, this is this series versus this series or whatever. And yes, technically there's like the subject header and you could do magical things. But like lots of people use, Outlook, which is garbage tier email client. and garbage tier email clients don't give you the ability to do that kind of sorting. And if you're expecting everybody to work from Mutt and have, scripty thingies to do things or using the Emacs mail client, I'm sorry to disappoint you. Most people don't do that. And so a big part of it actually kind of comes back to we still do email patch review. And that is probably the biggest contributor to the overload.
Yeah. There's one thing I like about reviewing patches on the mailing list, and that is that we have a permanent, publicly accessible archive of everything that was ever said.
Yes, that is very valuable.
Sorry, that's the end of me liking doing patch review on email. For everything else, pull requests are way better. But as far as junior engineers go, a thing that we've been trying in XFS the last few years is just rotating the maintainers around so that everybody gets to experience what that's like. And this is a way to get junior engineers on board because, 3 years ago when I burned out as being the XFS maintainer and stopped doing that, one of my parting gifts was sitting down and thinking about all the different roles that the maintainer plays in the project based on all the stuff that I did and all the stuff that Dave Chinner did before me. Yeah, it was on the order of AsahiLinux.
It's a very sad state when you're at that level.
It's a sad state when one subsystem.
Yeah.
Mm-hmm.
Yeah.
Well, that also gets back to the misaligned interests. But so I realized like, oh yeah, in a normal software engineering org, you'd actually have someone doing the triage. You'd actually have someone watching the dashboards. You'd actually have a few senior engineers doing
They're all
whatever.
different people.
Yeah,
Yeah.
these are all.
Yeah.
Mhm.
Yeah.
And and then I thought, okay, well, take all these roles and fill them with the people who are doing it. And wow, we're at about 40% staffing on a major file system that's been around for 38 years.
Almost 40.
Mm-hmm. And that's not good. Then we look at then we look at EXD, and it's kind of just Ted. So,
hey, you're
so-
doing okay.
So, I think a good thing. I think it would really help if we actually split up these roles and started handing them out to people to just say, okay, you know what, you're in charge. You own this part now, and this is how you're going to level up to the next level and turn into a cranky old graybeard like me. Wait, don't say that part.
That's something that I think we should be looking more towards in Butterfest. We have lots of people, but only one maintainer, which is weird.
Mm-hmm.
I have a question. So on the same subject as junior engineers, they're recording this, darn. Do you really want junior engineers? I'm a professor of computer science. Are you sure you really want junior engineers? Or do you perhaps want more seasoned engineers that are stolen from elsewhere and that you sort of slurp into your project? Or do you want them before they get burned out?
I want to see more junior people because junior people have ideas. Senior people just, get angry and curmudgeonly. But in all seriousness, right? Like if you have junior engineers coming in, they're going to come in without preconceived notions of how things should work, and they're going to challenge you. And you should be challenged. They should be talking back to you. They should be saying, hey, this doesn't make sense. Why are we doing this?
Mm-hmm.
Because if that never happens, you don't improve. And yes, we should obviously have senior engineers because they need to be mentors, but having more new people leads to more change.
Yeah, we do need the junior engineers because they don't know how the system works, which means they're incredibly good at finding all of the holes and all of the burning garbage cans that we've accidentally left behind. But we do need to treat them a lot more gently, and we need to treat each other a lot more gently.
It's back to being resource constrained that truly junior engineers need attention and mentorship.
Yeah.
And if you can't keep up with a mailing list, the idea that you're going to be spending half your time crafting this person. So the junior engineers that end up succeeding that we've seen over time are already self-sufficient. Yeah. So junior, how junior are you if you can land in this environment and be productive by yourself?
It's one of the sort of things we do with our company is that people, the new engineers get put onto a project with somebody who's already been working on these things, doing something that might end up being upstreamable. So we've done work with QMU, things like that. And we're doing some work with RISC-V I'll talk about later. And we just get people, and some of them will like it, some of them won't. But we hopefully will get some people involved. So
yeah, a lot. Oh yeah. So one last parting shot about that. Nowadays, it is amazing to me to help junior engineers get started because we have so many more automated tools and cloud and virtual machine resources all over the place. Like it took me 3 years to actually build a reasonable-ish mechanism for testing file systems, and now I can point our new junior engineers at, hey, this Luis guy, the one right there, has this KDevOps project where you can just feed it a few parameters and it will go and provision all that stuff for you so you don't have to figure out how to do that on your own. That means you can actually go start poking on the code and asking questions about why does this do that? What if I add this patch? Well, okay, write the patch and throw it at KDevOps and see what it does, instead of laboriously figuring out how to configure your kernel and then go deal with the distro kernel installation policies versus what the upstream kernel spits out. So that has been a huge change in everything I do in my job since 2017 or so. All right, I'll actually get to Josh now.
So going back to the item of something other than patches on a mailing list, I still remember in the early days of talking about like why do we not want to be using GitHub or GitLab or something, like the stated rationale was because on a mailing list, if you stop talking, you disappear out of my inbox and I can ignore you, whereas an issue sticks around even if you don't, which is really sad. Like we want mailing lists so that we can lose things. Meanwhile, like some subsystems have actually had some really good success adopting like their own GitLab and similar and using that downstream and then feeding the resulting tree up to upstream maintainers. I'm wondering for the subsystems where they don't want to have to do all the work to integrate that themselves, could we get a gitlab.kernel.org that is the official host for anybody who wants to flip the switch and use pull requests, and then start integrating CI into it, start integrating like if you submit something under FS, it will automatically run XFS tests.
That's going to be tough. Yes, you can build that and tell people about it.
So it doesn't, basically, we should be free to do any of that. And part of my talk will also talk about the CI stuff. So if you wanted that, pretty much that is like pretty much automatable now. So yeah, that should be possible. I don't see any barrier to that. I think the only gripe would be making sure that the merge commits, right, look nice for Linus, right? So long as he's happy with the merge commits, and I don't think he would care.
Well, I think the other big gripe would primarily be have a big switch where each subsystem can say, I do or don't want to take pull requests. And then, you know, anybody should be able to trivially opt in, but you'll get less friction if you have to opt in.
Yeah, well, DRM has been considering doing this for a couple of years now. Nope, not yet. Joseph is sure. Joseph is working on it, and AsahiLinux is entirely developed through pull requests. We do not use mailing lists for development. The challenge here is that there is no interface in the maintainer's file to describe that you don't take email patch review. That is a requirement. The maintainers, and that is a discussion nobody wants to be the first one to start. That's really what it has come down to, because once that discussion is started and we land on it, you're going to start seeing subsystems switch over like that. But it hasn't happened yet because no one wants to be the first person to bring this up.
Well, it's true. I did not want to be the first person to stick out our neck, but XFS does actually take pull requests now. But we actually did have a discussion about, do we ban all email submissions from now on? And we came down to, well, there are some people who actually just have some itch to scratch and they want to send one patch. We can let them still send email because that's the way it's been done forever, and it's really not that much of a cognitive load. If you want to send big things, that's where things get murky, where some of the XFS developers would rather send pull requests and we just go review things, and some of them don't want to do that. And also, actually, it turns out that a big stumbling point for XFS was the lack of permanent public archives for that, because they are leery of GitLab and GitHub because there's no gitlab.kernel.org, which, you know, that's a solvable problem. They don't want to trust GitHub because Microsoft, understandable.
Yep.
And so that's kind of where the let's just review a pull request thing kind of breaks down. But I will share that the way we do pull request-ish based reviews is developers will push a branch to whatever their favorite Git forge is, send email to people to say, hey, can you go look at it? And then we just go, do the, control select in the web GUI, paste that into an email and say, okay, I went through this patch by patch, and here are my comments for each of those patches, send. Which is a really clunky way
when Joseph does a big enough patch set, I just ask him to do that, and he gives me a GitHub branch, and I basically do the same thing. Yeah.
Mm-hmm.
Yeah. Yeah. For Btrfs, we have started accepting pull requests for the user space tools. We haven't done it for the kernel yet because we can't agree on how we want to workflow this. It's really, really challenging. For the user space stuff, what we've done is GitHub is configured to do rebase merging. So no merge commits. And we still apply the same standards for commit messages that you've had before. So effectively, it looks the same as if you just applied things using Git AM, right? For the kernel stuff, I know Joseph has been on, in the whatever counts for spare time at this point for him. Poor guy is doing like 4 or 5 different things that are not Btrfs related while doing this. He's kind of trying to come up with an apparatus where he can have things submitted through GitHub pull requests, have it run through the CI apparatus that we've now developed for Btrfs based on using Fedora and Fedora Asahi Remix to test all the variations, and then have it basically create a qualifier before it gets reviewed and stuff like that. And that stuff's hard. Like coming up with the mechanics of doing this and having it work right. Like we've been at it for 5 years now and it still doesn't work right enough for us to trust it. So like it's an ongoing challenge. And I think all the other file systems have similar problem spaces where like, we want to take the mechanical parts of qualification out of the human hand with moving to pull requests or merge requests or whatever terms you want to call this. And that's the hard part. Like once that part's done, we've basically solidified, okay, how do we take patches? How do we land them? And then we go from there. Like that's the easy part. The hard part is
getting to
qualification.
There. Yeah. I mean, the XFS CI is every day at 4:30. I go and pull a bunch of stuff and start my dumb bash script that pushes everything. And yes, sorry, Louis, someday it will be just pushing it to KDevOps, but it's not there yet.
The hopeful
But
note I'd offer is that you said a bunch of people are using Mutt or Outlook or whatever.
Yeah.
Fine. A whole bunch of core people have subtly shifted over time and are using all this kernel or infrastructure, so they don't go anywhere near SMTP.
Yeah.
It's all weird back-end database stuff, and so it may be a lot closer than you think to have automation around this stuff, so it isn't just
Weird.
list and archives being the front end.
Yeah.
That tooling, if someone really got a bug in their bonnet and did it for 6 months,
Right.
there's a platform for it.
Also, just FYI, we are 2 minutes to the start of the next session, so if you would all like to take bio breaks, then we should probably break now.
Hopefully this question is just short and sweet. File systems. XFS has a reputation for being just extremely reliable to the point of being unexciting. And if you're a system administrator, unexciting is exactly what you're looking for. So my question is, if Btrfs is so great, why was it added only as a technical preview in RHEL 6 and then taken out of RHEL 8 and left that way?
Oh dear.
All right. Because Red Hat's Btrfs engineers were all poached systematically over 5 years. So once they had no more people, they just stopped. That was it. Very easy.
All right.
Or I guess not.
I mean, I don't know what. Sorry, was there one question at the back? Okay.
Okay.
Well, thanks for coming, everyone.